welcome to my Windows Server 2012 video series. This time looking at building a geographically dispersed cluster, a multi-site cluster or a multi-subnet cluster. My name is Paul Gregory. I'm a Principal Technologist at QA. So first of all, just to set the scene a little bit, in terms of building this multi-site solution, you can see that I have a data center as my primary functional data center on the left. I have my DR data center on the right hand side. So my primary data center obviously could be made up of multiple cluster nodes. In my scenario, I'm just going to have a single node with some storage behind it, sitting on a 172.16 address with a /16 subnet mask. My DR data center again just has a single node in it. Again, could have multiple nodes in the data center if you wanted to, and again has got its own set of storage. So a key scenario here is quite often when you're building geo-clusters, there's no shared storage. Now, one of the challenges you have with clustering is because it works on a vote-based model, you need to make sure your cluster always has an odd number of votes. So to give it an additional vote, because obviously I've got my vote for my node in data center A and my vote for my node in data center or the DR data center, so that's 2 votes. To get my third vote, I'm going to use a remote file share. The advantage in using a remote file share, maybe over a witness disk, which you might be familiar with, is the remote file share could be stored at a third location. So therefore that allows me to detect failure inside the network, and hopefully avoid situations where you'd actually get split brain scenarios where 2 halves of the cluster stay online and start to diverge, even though they can't communicate with each other. So that's the basic configuration that I've got within my demonstration that I'm going to be doing shortly to try and show you how to set this up and how to configure this. I guess there's one really important point that needs to be clarified right at the beginning. In order for this to work successfully, you need to have some technology which is going to replicate data between your cluster nodes, e.g. from my storage in data center A to my storage in my DR data center. That replication can be delivered through your storage solution itself, so maybe your SAN infrastructure has a data replication engine. This could be replicated through a software layer, so this could be, for example, a product from someone like Vision Solutions, so double take availability, for example. Alternatively, this could be dealt with at the application layer, so you could be using features like always-on availability groups in SQL Server 2012 or database availability groups, so DAGs in Exchange 2010, for example. So it would be a case of you'd need some additional layer. I don't have that layer, so we'll just see the configuration from the point of view of the cluster. On a final note, with respect to this style of configuration, there are some decision points around whether you actually have the same number of nodes at each location, or whether effectively what you want to be your primary site, so in my case data center A, if I actually have a greater number of nodes. Obviously the advantage in having a greater number of nodes at data center A, it ensures I get local high availability, but I get disaster recovery capability at my DR center. And there's some of the design decisions, but we're not going to go into those today. So let's jump over and hopefully go and do some demonstrations of this particular technology. Okay, having switched over to one of my cluster nodes, we'll start making the configuration changes required. So both the nodes are connected to shared storage. Both the nodes have the failover cluster software installed. So the first thing we need to do is obviously launch the failover cluster management console, and this will allow us to use the validate configuration tool to confirm the cluster configuration. Now the reason I'm doing this is the validate cluster configuration tool does assume that if you run all the tests that you have shared storage. So you will see that effectively a percentage of the tests will fail, but the system will still come back and tell us that the cluster is valid for, or that the nodes are valid for building a cluster. So the first thing we're going to do is we're going to add the 2 nodes into the cluster. So my nodes are imaginatively called LUN-SVR3 and LUN-SVR6. So they are the 2 computer systems we're going to add in to build the cluster. So now, having selected the two computers, save that configuration, the cluster tool will go out and check to make sure that they are valid machines, the cluster software is installed. So we're going to choose to run all the tests, and we'll then just get confirmation of what we're about to do. So because all the tests are in there, obviously all the networking tests, all the storage tests are in there, as we can see. So we will actually initiate the testing and see what happens with the storage tests. Now, one of the things with the cluster validation tool, if you've never run this, you'll notice when the test progress, you'll either get a green to say the test has passed, or you'll get a red to tell you that the test has failed. However, tests actually have three states. They have green for pass, red for failure or error, and yellow for warning. So even though some of the tests will be highlighted in red, there's a high chance that they will just be warnings, and therefore the system will make a perfectly valid cluster. So this takes a little while to run, so we'll come back once this process is complete. So we can now see that the cluster validation process is complete, and it actually tells me testing is successful. If I press the view report button, we will actually see that we've got some substantial warnings. We have warnings around the disk subsystem, and the reason for the warnings around the disk subsystem are because we have no shared storage, as already mentioned. We also have some warnings around the networking, and that's because my systems only have a single pair of network interfaces, so that's basically a single point of failure, so it doesn't sort of really meet the best practice requirements. You'll also notice I have a warning about system information, and that's because I don't have quite the same patches installed on each machine. So here's effectively just the warnings around the disks, really just telling us that there is no shared disks. Okay, so for what we care, or what we're building, we understand that, we accept that's a limitation of the test wizard, so there's nothing we can do about that. But effectively everything else on the nodes passes as far as we're concerned. So you can see there is a box which basically says create a cluster now using the validated node, so I'm just going to press finish, and that will actually launch the create cluster wizard. So obviously past the welcome screen, we'll go and give the cluster a name. So I'm actually going to call this particular cluster a datum Geo-Cluster, and we can see the two networks that the cluster nodes are plugged into, so 172.17 and 172.16. So I'm just going to define an IP address for each of the nodes from the point of view of management. Okay, so we'll just save that information. Hopefully it will go and validate the name's unique, and it will validate that the IP addresses are unique. So that's all there is to it. So the system will now go out, and it will actually build the cluster. There was a tick box at the bottom of the screen which sort of said add all available storage. So the storage which is available on the first cluster node and the second cluster node will be added in as available storage, and we'll see that when we look at the storage node once the cluster's built. So this will take more than likely about another 20 seconds to go and build the cluster. So having created the cluster successfully, we can now actually go and make the configuration changes we need because of it being a geographic cluster. This will also include provisioning a service. So what we're going to do is we're actually going to provision the cluster as a file server. Now again, as I mentioned at the beginning, I don't have any data replication service, so there'll be no data actually being replicated between the two systems, but all of the cluster configuration will be shown as built as if we was going to do that. The key thing that allows this to work is actually dependencies of resources. So when you build an application and put it into a cluster, we connect a name for that resource, we connect the nodes that resource can run under, we connect the IP address and the storage. So the key element here is we now have the ability to use ORs in terms of building the relationships. So hopefully we'll see that. So if we go to the storage section and go into the disks object, we should see the storage that's available for each of the two systems. So you can see my two disks. You can also see that they're both basically got the same owner. So effectively only one of the disks can come online because only one node has access to that storage. The other set of storage is not directly available to that node. We will sort that configuration out as we go through the build process. So now we're just going to go and configure the file server role as being highly available. So I select file server, and we're going to build this as a traditional file server in a cluster. So we're going to build this as a high availability file server as opposed to a continuously available scale out file server. So there's going to be what we call a file server for general use. So again, we give the file server a name. So we'll imaginatively call this a datum fs01, and we give the file server an IP address. So again, we have to give it an IP address that's valid on each of the different subnets. So just go and fill those values in. Oops. So 201 and 201. The last octet doesn't need to be the same, they could be different. Obviously I'm just doing it for consistency across my build. So hopefully again we'll just validate those resources are free, and you'll see it will only allow us to add the one disk that's online. We can't actually add anything else to the system. So we'll just add that one disk, and we'll go and create the file server resource. So we can see the file server resource is just coming online. So it's just configuring the IP address, the names, and bringing the resource online. So hopefully that's completed the configuration of the resource. And when we go back to the previous screen, we'll see its status is pending. So effectively this resource is hopefully starting up and will be online very, very shortly. So there we go. So we can now see the status is running. So if we select the file server, if we look at its current owner, so LUN SVR6, if we look at the resources that it's consuming down the bottom, so just go to the resources tab, we can actually look at the disks, the names and the IP addresses that are being consumed. So effectively at the moment we just have the two IP addresses that we've allocated and the one piece of disk. Again, you'll notice only one of the IP addresses is active, and that's because that's the IP address that's attached to LUN SVR6. The IP address 172.17 is SVR6's, 172.16 is actually the IP address allocated to LUN SVR3, so that's why it's not online. So you can see we have this OR relationship now between the objects. So we've got an OR between 172.16, 172.17. So only one of them needs to be online for the cluster to be valid. If we look at the dependencies for the file server resource itself, you can actually see there's an AND dependency connecting it to the cluster disk. So we really need to complete two steps here. So the first step we need to do is we now need to go and add the additional disk storage to the file server role. So effectively select the disk, and we can actually go and add this to the file server role. So assign it to another role, and we can attach it to that file server that we've just built. You now see it's assigned to the file server role, obviously still in an offline state. If we now go back to the role, we can see that we've got the two disks down the bottom. So what we can now go and do is we can go and change the configuration. So you can see we've got a current status of partially running. The reason for that is because the system knows that if we was to fail over, the other disks wouldn't be accessible. So what we can do is we can go to the dependencies tab, we can add in a new entry for the second disk, so cluster disk number 2, and what we can do is we can make the disks an OR relationship. So effectively only one of the disks has to be online when the file server role's running. Okay. So hopefully when we save that configuration, that will now change the status of the cluster to running. So the system will now sort of understand how the objects are connected together. So if I now actually go and move the role from one node to another, so I'm going to move it from node 6 to node 3, what we will actually notice is the role goes offline, will then bring up the other IP address, the other disk, and when those resources come online, we will then actually bring on the file server name. So you can now see the role has switched to LUN SVR3. Again, obviously if I was to go and move back, exactly the same process would occur, switching us back to the other roles. Now you do notice against the disk we do get a warning that effectively telling us that the disk storage is not connected to the node. So effectively cluster disk 2 is not connected to machine 6 and cluster disk 1 not connected to machine 3, and that's how we expect it to work. If you want to tidy up that informational message, we can actually go in and edit the properties of the disk resources and again change the relationship. So again what I can do is I can actually specify the relationship between disk 2 and, for example, the IP address. So I can say that cluster disk 2, and I can go and put an entry into the box, is effectively going to be tied to the 172.16.0201 IP address, and then obviously I can go and do the same for cluster disk 1, but obviously this time set it to the 172.17.0.201 IP address. So now the cluster understands exactly when these disks should be online and when these disks shouldn't be. So if we just save that configuration and then we just go and do a single failover, and that will then just effectively erase the message. The message is effectively the last status that was reported. So in order to get rid of the message, we need to update the status. So effectively that will then cause the message to disappear. So hopefully when it switches over, we'll see all the resources go offline, come back online just as before, but you'll notice we don't get the warning message. So that's now completed the demonstration of building the cluster. So hopefully that's been useful for you. The only thing we've not done is actually gone and set the quorum model, but that would be very easy to go and do over at the Adatum Geo-Cluster section. So really simple change to go and make. So having now seen the configuration and the basic setup of the geographically dispersed cluster, a couple of things that you might want to consider. You might want to consider changing elements like the time to live record. So effectively you might actually want to use the set cluster parameter host record TTL, so you can change the time that DNS records live on a workstation. So by default DNS records live for 1200 seconds on a client before it will requery DNS to see if there's been a change of IP address. So we could say maybe bring that down to you know, just a few minutes to try and speed up the failover capability. Also, the other thing to consider is, because I've now got a geo-cluster, my applications are going to have different IP addresses depending which subnets they're on. So do I want to register all of the IP addresses for that application in DNS? Again, if I chose not to, I could obviously be tied up into Active Directory replication delays before the new IP address gets synchronized across. It's also important to remember that communication between cluster nodes is unauthenticated and unprotected. So you might actually want to raise the security level for the cluster for intra-cluster communication, so we can actually use high levels of authentication and we can use encrypted traffic between the cluster nodes. The last thing, which I've not put anything on there because I don't want people to rush out and do this, is but you might want to consider changing the cluster heartbeat. If you've got high latency networks, you might want to consider actually changing that cluster heartbeat value. So the default cluster heartbeat is 500 milliseconds, and 3 heartbeats have to be missed in order for the system to determine there's a failure. So you'd need a really high latency network for that not to be good enough. So again, bear in mind, if you choose to change that, that obviously will extend the time it will take for a failure to be detected. So thank you very much for watching this video. Hopefully this video has been of use to you. As always, please feel free to contact me, paul.gregory@qa.com, where I'm a principal technologist. I do have a blog on the QA website, which you're more than welcome to have a review at, and please feel free to follow me on Twitter. Thank you very much for watching.